Hello. So in this project, I will be showing you how we perform zero knowledge proof and then verify zero knowledge proof and all the things related to that for generating and proving using zero knowledge methods for age and nationality, basically for passport and age without revealing our actual data. And for this, I will be using Circom and SnarkJs, and my circuits will have been verified through Picus. So our circuits have been verified through Picus. So this is the age verification code. As you can see, these are the private inputs, and these are the public inputs. This is the output, and this is the code. Basically, it converts the date into a string, combined. The date string into an integer, basically that like holds the chronological order. So in the format YYY holds the complete chronological order, so we are using that. So okay, so this will be like what I will be using. This is the, and then it can performs equality and greater than equality check, and then sends the output. This is the constraint, and make sure that output is only binary. Then this is the nationality check. It just takes, I am using the ISO, like we are using the ISO standard nationality codes, and here it is the actual country code. Then with the private input, the public input is the required code. Then there's the signal check. Now we are using this logic because when done earlier, Picus was having problem with under constraint, like it could not clearly verify if it was constrained properly or not. So I am using this check. It basically performs a greater than equal to check between both the hands, and then multiplies them, performing AND, and gives true only when both of the above equations, both this and this is true. So I will start by, these are all the commands which you can like use to copy this on your system and like perform this on your system. So first of all, I will be using like running age verification and nationality verification parallelly. So this is the, for age verification, this will be for nationality verification, this will be used later. So first of all, we will like compile this using Circom library. So I will just copy this code and paste it here, and I will perform this. As you can see that it has returned the code successfully, and we can see that it is like here the files are here, the verification.js file, the r1cs file, and the sysm file, then sym file, then the symbol file for debugging. Then I can use SnarkJs to basically check for the circuit information and the constraint information. So this is circuit, 46 wires, 40 constraints, 3 private input, 4 public inputs, 51 labels, and 1 output. Then I can print these constraints outright using SnarkJs once again, and I can do this. And these are the constraints. A lot of gibberish, like for naked eye it looks like a lot of gibberish, but all of these are the 40 constraints which are there. Now I will then do the same for the nationality verification. I will put it here and then just a problem which will be there, like so it is written now correctly. It is showing like it is, again you can see in the build section the nationality verification has come. We can again use SnarkJs. These are the constraints. There are 140 constraints and one private and one public input. Then I will go here and use to print the constraints, and again as you can see, so much gibberish for the naked eye. Then I will then once our both files are like basically we have basically compiled both the circuits, we can use Picus to actually verify them. So I'm in the Picus directory. Make sure you have Picus installed. I have built it on the system from the source, and using Rust and Cargo. So I will use the racket command and this, and I will just run the Picus, and yes, it's properly constrained and exited with the code 8. Same I will do for the nationality verification part, and okay, so nationality verification, again it is also constrained. So we will once this is done, we will move on to the next part, which will be creating the, which is introducing randomness, and we will using the tau and powers of tau ceremony. This is a universal setup which I will be doing in this window only, and it will be automatically done for the entire system. So I will just clear out this window. Okay, so now I will start with the starting with the new ceremony. So I will be using the BN128 curve, and the 12 here means it can support 12 circuits. And this is the file which I'm creating. So I will enter this, and yes, the file has been created, and the hash, the initial for challenge hash has been created. Now I will contribute this to the ceremony. The contributing to a ceremony basically increases the randomness, making our circuits more like introduces more randomness, more secure to attacks. So I will perform the contribution. Now, once the contribution has been done, I will now prepare this ceremony for the phase 2. What is phase 2 is basically, it is not, this is phase 1, which is a universal setup, which I'm doing for all the circuits. Now phase 2, I will be doing it like introducing this randomness to the specific circuits which we have compiled earlier. Okay, so I will prepare it for phase 2, and I will create a final p-tau file, and this will take a little bit of moment, but it will be finished pretty soon. Now once this has created the final p-tau file, as you can see, I can go in the keys in my build section, and in build you can see that there is the p-tau final file here, which is basically a binary, which I can't obviously open here, but yes. So I will again go back, and now I will verify if the ceremony was performed correctly, and for that again I will use SnarkJs and powers of tau. And I will just enter it, and yes, so powers of tau is okay. So what all these files did was, like if we go again, this created new power of tau file, started a ceremony. We did our first contribution with introducing randomness for using base 64 randomness. Then we prepared it for phase 2 for a specific circuit, and created the final p-tau file, which we will be using further while creating our specific verification key for each circuit. And once this was done, we used the power of tau once again and verified that our file was correct. Now with this done, both our circuits are ready for like starting for creating a witness, and then for preparing our verification keys, then creating witnesses, and then moving forward. So I will move forward. I will just clear both of these out, both of these windows out. So now we have the power of tau universal setup complete. Now we will go with the age verification circuit setup. So we will use this command here, which is SnarkJs Groth16. We are using Groth16 protocol. We will use we will set up the age we will use the age verification R1CS, which we had compiled earlier in the first section, and then we will use the power of tau final key, which we had just prepared, to create the age verification to prepare the age verification key, which is age verification _0 Z key. So I will use this and then run this. So this has created this file, which is the age verification 000. Then I will do the age verification age contribution, again contribute to the to this newly created key using our original key, and we will also original key and the final key. So age verification final key and the original key. So this will create the age verification final key. As you can see here, we used the p-tau the port 12 0001 and 0000 to create this final key. Now we will use this new contribution to create a age verification final Z key. So as you can see, this has been completed, and we have age verification final key. Now we will verify this age verification final key is correct. So we will again use Z key verification, Z key verify, and use the age verification circuit, the p-tau final, and the final verification. So basically use this circuit, and this circuit here, then the final p-tau file, then created the age circuit Z key. So we'll enter this, and Z key is okay. Now we will go to do the same for the nationality verification. So we will go back to the nationality verification. I will quickly perform all of this again using SnarkJs and Groth16 to create nationality verification key, then using the nationality verification contribution to basically nationality verification contribution to basically create the nationality verification final Z key. Then we will verify this final Z key. We verify this final Z key. Okay. And Z key is okay, and then we export it. Now here we also verified, and here we verified. Now in the age one also we have to export this verification key to a JSON, so which we can use later when we will be creating witness to finally check for our to like create zero knowledge proofs and to verify these zero knowledge proofs. So this has been created using Groth16, and here is the verification key. This verification key will be used in the following sections. Then we will go to this again. We will verify this, and we will do this, and okay, so we have both the keys now, nationality and age verification. Okay, so now we have both the keys ready. Now we perform actual witness generation and proof. So for this I will be using this sample data which I have created. So this is a sample data. It is of someone of birth year 2014 with 5 birth month 5, birth date 15, current year this, and minimum is this, and the nationality, which nationality it is 36. Both of these are supposed to give false as an output. So let's see how we go about that. I will clear this once again, and I will clear this also once again. Now I will go with the age verification. So here is the so what we will first calculate the witness. So what it's doing, it is using Node.js node to like using the age verification JS file, which is the generate witness file, which was created when we compiled a circuit, and then we use the input data, and then we build it in age verification witness file. Here our age verification witness file will be created. Now when I enter this, as you can see, age verification witness file has been created. Here it is. Age verification witness file is here, again a binary. Now we can now this is the witness. Now we will generate a proof using the Groth16. So again we will access Groth16 using SnarkJs as we used earlier. We'll Groth16, we will we will generate a proof. We will use the key age verification Z key. We will build use the age verification witness. We will use the age verification proof, and with this will create age verification proof JSON and age verification public signal JSON. So when I enter this, our files have been created in the proof, and as you can see, these are the two files which I will be sharing to the verifier, which they can verify and which I will show in the next step. So as you can see, clear the public signals give. This is 2025, like the today's date. So 2025, 11 and 10. Then minimum requirement is 18, and the current like the output is 0, because if you remember, we shared it originally. The age proof was this, like birth year was 2014, so no one from 2014 is going to be this old yet. So, and this is the the proof part, which has the keys, encrypted portions, which will be used to verification. So these two files are shared. Now I will use this the verification key which we earlier generated, the proof and the public signals, to verify it, which will be this command. And when I enter this, it should give OK. So this OK means that whatever this file is saying, that yes, this person on this date is not above this age as of now. Okay, so this was for the age verification. Now again, if I go for the like nationality verification, I will use this, and I will go again like this, nationality proof input.json. I will use this. So it created the witness file here, as you can see. Then I will generate a proof. Again, it should give false and only reveal the public data, which is the it should only reveal the public data, which is the required country code, which is 355. So it should not reveal the 32 number. And if I go to the public section, so there is 355 and 0 means the person is not from there. Again, these are the extra knowledge, the extra information that needs to be shared to verify the proof to the verifier. Now I will verify this, and as you can see, it will say okay. And okay, so this was done. So with this, we have actually completed the proof, and as you can see, only in the publicly available information, only these files will be required, which is the nationality verification key, the nationality verification public.json, and nationality verification proof.json. Nothing related to the original information or the original data is being revealed, and this makes sure that we can use this in any scenario and can verify the age and the nationality without revealing any extra information. Okay, so now this whole system was further implemented in modular UI based system. So the zk passport like code is being used like portal. So what it does is it is the prover section, where a prover creates a proof. This is the verification section where a verifier can upload their verification, the public signals and the proof, and they can verify if it's correct or not. So let's use the generate proof section. So I will just select a random date and an age. Let's just I select 2000 2000 September, and random date like 19 September 2000, and then I select 18 as a minimum age. So this should turn out to be true. So it is showing true that this person approver is on this date is above this date 18. Now 18 is this will make sense in just a second why I'm putting 18 here, and this says it is true. Now I can just click here, copy the proof, go here, paste the proof, and it will be here. So I can just click on verify, and it is saying the proof is valid and meets the age requirement. Now why this was here, I can just change the age to be, let's say, 60 years old. Someone needs to be 60. So obviously it will come false, that the prover can accurately prove that they are that on this day they are less than 60. Like on this day they are for an minimum age of 60, they are less than that. So I can just copy the proof, again go to the verify the proof, and then paste it on the clipboard, and then I can select verify. So the proof is valid, but it does not meet the age requirement. Now if I just change some things like so I can do this, so it will make the proof also invalid. So no one can actually use this to find out what my correct age could be. I can do something like let's say instead of 11 I will change it to 9, which is my correct one. I will again say it will not give the information. I can go for nationality. I can select my country. Let's say I am from Canada, and the country required in some application to check is also Canada. So I will create nationality. It will give 1, and it will reveal the Canada's 124, like the public input on the necessity. I will copy the proof. I will go. I will select everything else, and I will paste here. Sorry, I will paste it in this one, and I can just click on verify. So it will cryptographic valid and nationality matches Canada. Now if I just go something like let's say my actual country is Japan, but I'm selecting Canada. I can generate proof. It will give 0 and 124 is the Canada's ISO code. I will copy this proof. I will go to verify proof and I will paste it here, and I can again verify. So not from the required country. Now this is currently me putting the data, but it can be implemented with the backend having the passport data and just generating the proof from the passport details and nothing else revealed. If I just change it to, let's say, 1 or something else, it will make the proof invalid. It will make the proof. So this is the ZK passport system also, and all these codes are available in the repository. You can just run this code if you run app.js. So if you run node server.js in this one. Okay, so thank you so much. This was our presentation for the ZK passport system. So if you go here, you can just you see the file. This file is available here. This is the prover.js and this is the server.js file, and this you can use to make sure everything, like to run this on your system. Make sure everything else is set up. To read the readme file and make sure you have Picus, Circom, SnarkJs and everything else installed. So thank you. This was our project. Thank you so much.